So good morning everyone and welcome to this lecture. In this lecture we are supposed to talk about friction. This is lecture number 3 and in all probability we should be able to finish what we started 3 classes ago. The topic of friction, if you remember correctly, we were discussing this problem in the previous class where I gave you what? I gave you a block of mass m kept on an inclined plane and angle theta, and I told you that we have done the same problem before, but in the previous problem that we did, there was no friction. This inclined plane was smooth, and we calculated the acceleration of the block. We have to do the same thing again, but now it has an angle of inclination theta. Anyone got the answer for this? Let me not wait a single second in doing this because I've already given you so much of time. So how are we supposed to do this? So what I will do is I will draw the free body diagram. This is mg. Everyone knows that this is mg cos theta. Oh, not mg cos theta. See, I'm confused. This is mg sin theta. Then I have this component, the perpendicular component, which is mg cos theta. And then I have this normal reaction coming from ground. Everyone understands this? Yes or no? Huh? Now remember, this block, because of this mg sin theta force, wants to go down. It wants to move down. It will move down. Someone will try to stop it. Who is that someone who will try to stop this or resist the relative motion? What is that thing that will resist the motion? Will someone oppose the motion, or it will go, okay, go, you are free to go? Or will someone oppose the motion? Yes? Hey, it's a simple question. Will someone oppose this motion or no? No answer. It's supposed to go down. Will someone try to stop it? Will someone try to oppose this? Yes or no? It is such a difficult question to understand. Answer is either yes or no. Whether some force, something will try to stop it or oppose it.
Yes, sir.
What? What is that thing that will try to stop it or oppose it?
No.
Yes? What is that thing that will try to stop it or oppose it? No idea? No one knows this?
చెప్పినా ఒకసారి friction opposes.
Okay, thank God we got an answer at last. So it is the friction force that is going to oppose it. In which direction it will be applied? Let me just rub this one. So what is given to me is the value of the coefficient of friction is given as mu k. Now friction will try to oppose it, so the frictional force will be backwards, Fk. Now can anyone tell me the value of this Fk? This kinetic friction. What is the value of this kinetic friction? Yes. You've already done this, so just give me the answer fast. What is the value of this kinetic friction? Fast. What is the value of this kinetic friction?
Mu k n, sir.
Okay, that is mu k into n. Now, can you tell me the value of n from the diagram? It is very evident. We have done it so many times. What is the value of N?
mg cos theta.
So the value of frictional force becomes mu K into mg into cos theta. Do we understand this, everyone? I just put the value of N as mg cos theta. We have done it so many times. So the value of frictional force is mu K into mg into cos theta. We all understand that this block is trying to move downwards. Its acceleration is downwards. Now I can write the equation for this block. It is supposed to go downwards. So what is the equation of this block? It is supposed to go downwards. You can see there is a downward force mg sine theta. There is an upward force which is Fk. So you can write the equation of this block. What will be the equation of this block? Can anyone tell me? Mg sine theta is downwards. Fk is upwards. Can anyone tell me what is the equation of this block? I'll wait one more. Yes. No answers?
mg sin theta is equals to mg cos theta.
It is moving down with an acceleration a. I hope you understand it. It's moving down with an acceleration a. The downward force is mg sine theta. So I write mg sine theta. The upward force is Fk. So minus Fk. If this block was not moving, if the block was in equilibrium, then this was equal to 0. But here the block is moving. So this is equal to m into a, where a is the acceleration of the block. So now I put the value of Fk mg sine theta minus mu. Let's just write it as mu, not as mu k. Mu into m into g into cos theta, that must be equal to ma. From here I will get the value of a. The acceleration in this case, the value of acceleration in this case will come as g sine theta minus mu into g into cos theta. That is the value of acceleration for this block when the block is rough. When the block is rough, now when the surface is rough, the acceleration is g sine theta minus mu g cos theta. If I compare it with the previous diagram, the diagram when the block was kept on a smooth inclined plane, and I keep on repeating this because many times this question has come. When the inclined plane was smooth, it was frictionless, it was also moving down. In this case, what was the acceleration? I told you in the previous class also. What was the acceleration in this case?
A equals to G sin theta.
Very good. In this case, the acceleration was equal to g sine theta because there was no force which was opposing it. So the acceleration was simply equal to g sine theta in this case. But you can compare this acceleration with the acceleration that we got now. It is g sine theta is same, but now we have another term minus mu g cos theta. This term has come because of the friction present between the block and the surface. Do we understand this? I'll give you a minute to note it down. Both the cases, you can write them together. You can get question on both the cases. Case number 1, the friction case, may be a bit tough for you to come in the exam, but that smooth case is a case which has come many times in your exam. Please note it down. I'll give you a minute to note it down. Have you noted it down, everyone? Okay, then here comes a question, and I hope you can solve this and give me the values. If you don't know the values of sine 37 and cos 37, I can tell you sine of 37 is 3 by 5 and cos of 37 is 4 by 5. So this is the information. If you need, you can use it. And here comes a question. You have got a block kept on an inclined plane at an angle of 37 degrees. The value of mu is given as 0.1. You are supposed to find out the acceleration of the block, and you have 2 minutes to give me the answer. Right or wrong, give me the answer. Doesn't matter whether the answer is right or answer is wrong. It doesn't matter. You must try. These are the questions, bacha, that you will get in the examination hall. And yes, do we have an answer for this one? Huh? No one?
5 meters per second. 5 meters per second square.
5 meter per second square. Okay. How did you get it? So you have to find out the acceleration. This is a simple case. You can find it out like this: g into sine theta minus mu into cos theta. You have to just put the values here and get your answer. So let us take g as 10. Sine theta is 3 by 5 minus mu cos theta. Mu is 0.1. So 0.1 into 4 divided by 5. So it will be 3 minus 0.4 is 2.6. So acceleration will be 10 multiplied by 2.6 divided by 5. So I think the answer would be 2.6 into 2, which is 5.2 meter per second square. That would be your answer. Anyone got this answer? No one? Do we understand this, everyone? Yes or no? Okay. Okay, note this down. I'll give you one more problem. Have you noted down, everyone? Okay, now let me give you this problem just to tell you the sine of 53 degrees is 4 by 5, which is same as the cos of 37 degrees. You remember this value. Similarly, cos of 53 degrees is 3 by 5, which is same as sine of 37 degrees. Now, in this case, can you tell me what is the acceleration of the block? You have 2 minutes to give me the answer. Yes, anyone with an answer? You can take G as 10 meter per second square and tell me your answer.
(7.0 meter per second square).
7.0 meter per second square. Everyone got the same answer? 7 meter per second square. Okay, I think it looks good. Let us check it out. So, how do I get the value? Acceleration can be written as G can be taken common. Sine theta minus mu into cos theta. I just put the values and I will get the answer. Acceleration is G is 10. Sine theta, sine of 53 is 4 by 5 minus mu is 0.5 multiplied by 3 by 5. So I know how, I hope you know how to solve this, yes or no? So what will I get when I solve this? Outside it is 10. Inside it is 4 minus 1.5. So it is 2.5 divided by 5. And the answer is 5 meter per second square. That is the answer that you should have got. If you have done any calculation mistake, please check. How many of you got this answer? Boys? No one? What are we doing? We are still in the class, no? Please tell me what you don't understand in this question so I can help you out. Is there anything that you don't understand in this question, beta? Please ask me if there is anything. Nothing, everything is good.
Yes, sir.
But I'm not getting answers, so I'm worried because you just have to apply the formula, put the values, get the answer, stay happy. I hope we have understood this question. Okay, let me see. Can I give you one more question on this? Let me see if I have some question that I have in the printed form. No, this is okay. I think it's enough. I hope everyone has understood the concept. Let us move ahead with the next concept. And remember this, the next thing that we are going to do, and you will remember it, and you will see many questions on this in your exam, that is known as your angle of repose. Yes, bacha? Anyone having any doubt? Angle of repose. Any idea what is this angle of repose that I have written? Anyone knows anything about this angle of repose? This angle of repose. I think you would be having a practical. I mean, in CBSE there is a practical on this, on finding out the angle of repose. On this angle of repose. Okay, on this angle of repose. What is this angle of repose? There's a practical that is to be done. I don't know whether it is there in your board. So what you have is, you have an inclined plane. inclined at an angle of theta. Now you have a block kept on this plane, block of mass m. Now what you do in this experiment is that this angle of inclination theta can be changed. So you have arrangements so that you can change this angle theta. This angle of inclination can be changed. Now, if the angle is 0, if the block is like this, if it is horizontal, the block is not going to move. But slowly, if you keep on increasing the angle of inclination, the block is, at some point in time, the block is going to slide. Yes or no? Do we understand this? At some point in time, the block is going to slide. If I can find something that can slide. Don't have anything that can slide. Okay, let's take this thing. This thing can probably slide. If this is your incline, and this is your incline, it is like this, and this is your stuff. It's kept here. I hope you can see this. Now, when the incline is horizontal, nothing happens. This does not move. But now if I slowly, here it goes. So at some angle, this what gentleman I had began to slide. Do we understand this? I keep it like this. So it began to slide. My phone also slid from my hands, and that thing also slid. So at one particular angle, this will start to slide. That angle is known as your angle of repose. Do we understand this? So the angle of repose is the angle of inclination of the plane with horizontal at which the block begins to slide. Do we understand this? I will show you. I forgot that the screen sharing was not on. So angle of repose is the angle at which the block begins to slide. I hope I made it quite clear. I had to suffer a lot of losses. My phone also broke. My floppy disk also fell, but I hope the point was made that this angle at which the block begins to slide is known as your angle of repose. And what thing you must remember about this angle of repose? This angle of repose, tan theta of this angle of repose is equal to your friction mu k ka value, or just write it as mu. The value of your tan theta is equal to, the value of your tan theta, the angle of repose, is equal to mu. That means your angle of repose We had also seen one more angle in the first class. What was that angle that we saw in the first class? This is angle of repose. What was that angle? That we saw in the first class. Talked about one angle in the first class. What was that angle?
Angle of friction.
Angle of friction. So remember, this angle of repose is equal to the angle of friction. Both the angles are actually same. That means in both the cases, it was tan theta is equal to mu. So tan of theta for angle of repose is equal to tan of theta of angle of friction, and that is equal to mu. Both tan thetas are equal. That means both thetas are equal. Do we understand this? Yes or no? Now, what type of questions that you can get on this? Well, you can get some theoretical questions on this. And what type of theoretical questions you can expect on this? So remember, have you noted this down up till here? Okay, note it down first, then I will tell you. Have you noted it down, beta? Have you noted it down? Shall we move ahead? Okay. So what you should remember from this discussion, if your angle of inclination theta is less than your angle of repose, if I would again try and do this, where is my floppy? Okay, so again I risk my phone and this. So if I keep the block like this, and if your angle of inclination is less than your angle of repose, this block does not slide. Do we understand this? If your angle of inclination theta is less than your angle of repose, the block will not slide. So that is what you will write. If theta is less than theta r means the angle of repose. Will the block slide? The block will not slide. Block will remain stationary. If theta is equal to theta r, then the word we use, block begins to slide. With zero acceleration. There is no acceleration because both the forces will be equal. So there is no acceleration. Now, the third case would be if theta is greater than theta r. Can anyone tell me what will happen in this case? When theta is greater than theta, yes. Looking at the two conditions that I have given, can you tell me what will happen if theta is greater than theta r? Huh? No one knows the answer. If theta is greater than theta r, block will slide, not begins, block will slide with acceleration. So now the block will also have acceleration while it is sliding. Do we understand this? Yes or no? Okay, I'll give you a minute to note it down. Have you noted it down, beta? Yes or no? Then comes this question. The angle of repose of a body is 37 degrees with an incline. What will be the value of mu? What will be the value of mu? And the answer is, huh? No answers? I'm waiting patiently for your answers, bacha. Is an answer coming from anywhere? Or shall I do the needful? Huh? No one with any answer. Okay. So how will I get the value of mu, bacha? Mu is equal to tan of 37. The value of tan of 37 is 3 by 4. Sine of 37 divided by cos of 37. The answer is 3 by 4. Do we understand this? Yes or no? No, yes? It was a very simple question. I hope you understand this. Then comes one more question. I will make the question. Shall we move on to the next question, bacha? This is the question. The value of mu is given as 3 by 4. The question is find the acceleration of the block. Find the acceleration of the block. The what? Value of mu is given as 3 by 4. What will be the acceleration of the block? Anyone with any answer? Nah? Anyone with any answer? Yes or no? No, yes. We have 1 minute. No one is giving any answer. What is wrong? Okay, then anyone? Any answer? No answers. Get the answer. Boys, girls. Anyone got anything that looks like an answer? Answer. Anything that looks like an answer. Calculation problem? Is that so? Finding problem in calculation? Or something else? Well, then I will give you this homework, this question as homework. And I hope that you can solve it at home. How many of you study when you go back home? Physics, especially? Remember, physics is one thing that you will have to do at home because it is all based on numericals. And if you don't practice these enough at home, you might find trouble in doing them in the classroom as well as in the examination hall. So I would hope that you would practice this question. The sheet is already given to you. I hope you are doing the sheet. How many of you are doing the sheet of Newton laws of motion? Everyone is doing it. That's great to see. Well, keep on doing the sheets. I think you have the sheet of friction as well in that. So try questions from that sheet. Solve as many questions because that is the only way you can become good. I'll see you in the next class tomorrow. I was supposed to finish friction today, but it could not be done. So probably in the next class, we would be able to finish it. Take care. Have a nice day. God bless you all. Bye-bye.